All right, good afternoon, everybody. Hope you all are doing well. Yeah, so today we'll be talking about balancing of redox equation. So when we are balancing redox equation, you should definitely know that we are dealing with what we call redox reaction. This right here, redox what reaction. And what is a redox reaction? Remember I told you before. I said a redox reaction is a type of reaction where there is transfer of charge. There's always a transfer of charge. Do you understand what I'm saying? Or you can see a redox reaction is a type of reaction where oxidation and reduction takes place. So whichever way you want it. So when we're talking about balancing of redox equation, definitely we're also talking about redox reaction, and we are going deep into the root, which is the major purpose for the redox equation, and that is what the oxidation and reduction. Good. So if oxidation and reduction doesn't occur, definitely there is no what redox reaction, and there can never be a redox equation. All right, so now when we talk about oxidation and reduction, if you recall, oxidation involves the loss of electron. Oxidation involves the what? Loss of electron. Now, take note, look at all those electropositive elements, like sodium now, Na plus. Okay, let me not use Na plus yet. Let me just use that Na. I get what I'm saying. Now, sodium on its own has 11 electrons, right? Protons, and protons are surely having the same similar number with electrons. So we use this number to represent the number of electrons also, because the electrons also have similar numbers with the protons. So now, if sodium now is 11, abi, now you know that for the first shell it will accommodate 2 electrons. Let me zoom in. For the next shell it will accommodate about 8 electrons. 1, 2, 3, 4, 5, 6, 7. I be 8. Yeah, it's 8 though. I'm already counting rubbish, but it's 8, sha. So 2 plus 8 is what? 10. And mind you, sodium is what? 11. And we've only counted what? 10. I get what I'm saying. So now, if we have 10, how many is left? We have just what? 1 electron left in its outermost shell. So the thing is that sodium can lose this electron. Sodium can lose this electron. And if it loses this electron, it will become octet unstable, meaning that you will only be having just this shell and this shell. This shell will be gone because the electron that is taking over this shell, this orbit that you are seeing here, has been transferred, has been removed. So because it has lost its electron, so sodium is what? Undergoing what? Oxidation. I get what I'm saying. So when sodium loses its electron, you will not be having sodium in its ground state. This normal state is called the ground state. So when sodium loses electron, it becomes Na plus, losing what? Electron. So once it loses electron, how many electrons did it lose? It lost just what? 1 electron. So you'll be having what? Plus E minus. That is why if they want to represent oxidation, they usually write the number of electron loss on the right hand side. I guess what I'm saying. So let's recap again. Oxidation involves what? Loss of electron. For example, sodium having 11 electrons. If you count it, it will be having just 1 electron in its outermost shell here. So if it loses that electron, it becomes an ion, Na plus. I get what I'm saying. So sodium, from here turn to what? Positive here, abi? Now remember, ground state of an element is always what? 0. So from 0 to +1, is that not increase in oxidation number? So as it's increase in oxidation number, then that is also oxidation. So don't forget also that if this is oxidation, loss of electron, then what do you call this element undergoing oxidation? So the element that is undergoing oxidation happens to be a reducing agent. The element undergoing oxidation happens to be a reducing what? Agent. I guess what I'm saying. So now let's move on to reduction. First of all, let me circle out the oxidation first. So just take note. Oxidation, loss of electron. Reduction is the next. And reduction happens to be what? The gain of electron. So when we talk about gain of electron, those elements that accept electron, and for example, those elements that accept electron is chlorine. I get what I'm saying now. So chlorine in its ground state. When you see chlorine in its ground state, chlorine is number 17. Abi? So as chlorine is number 17, the first shell is 2 electrons. The next shell is 8. Abi? The next one again is also what? 8. Then the last one, okay, the next one is not 8. The next one is 7, because we have 2 plus 8, that's 10. 10 plus 7, that's 17. So it's remaining just 1 for it to complete what? 8. So because of it is needing 1 to complete 8, it is electron deficient. That means it can what? Gain electron. And as the fact that chlorine can gain electron, it is what? Undergoing what? Reduction. I guess what I'm saying now. So now if chlorine gains electron plus electron minus, sorry for that, plus electron minus, I'm coming, plus electron minus. Now remember that this one is just needing what? 1, and this one we're also putting what? 1. But mind you, this chlorine that is here, the chlorine that is here happens to be, chlorine happens to be a diatomic element. That is why we are putting Cl2. I get it. Chlorine is a diatomic element. Monoatomic elements are elements that just have a single atom. Understand? But diatomic elements are elements that have what? 2 atoms to be stable. You understand? So chlorine now is 2. You get what I'm saying? So now Cl2 plus E minus to now give what? Cl minus. Now look at this equation. Is it balanced? The equation is not balanced because we have Cl2 here, we have Cl minus here, we have Cl, just Cl, we have 2 atoms, we have just a single atom. So how can I do this to make this thing balanced? The only way I can do it is that, okay, if I want to still maintain a single electron, I can just say, okay, half of 2 atoms of chlorine. Half of 2 atoms of chlorine is saying 1/2 times 2. So 2 cancel 2 is equals to what? 1. So you are automatically having 1. And 1 here is equals to what? 1 here. So that one is balanced. So another way you can do it is that if you have chlorine like this now, Cl2 plus E coming plus E minus to give Cl minus. Another way you can do it is that Cl minus coming. Another way you can do it is that, okay, this my chlorine here has 2. Okay, let me to go ahead and put what? 2. Do you get what I'm saying? Now, mind you, the charge, the charge 2 times minus 1 here is what? Minus 2. So that means chlorine has gained how many electrons? Chlorine has gained what? 2 electrons. So if chlorine has gained 2 electrons, this one will be what? 2e minus. I know some students might find this one confusing, but it's better you go for this one so that you not rack your head that how did I get 2 electron loss. Remember I said from the beginning that chlorine is just needing 1 electron to become 8, to become octet, and I did it for just a single chlorine atom. But here we are having two atoms, two atoms of chlorine, because chlorine is diatomic. Remember that in the beginning we always deal with ground state, that means the normal state. So chlorine is 2 atoms. So as chlorine is in 2 diatomic, this one is just a single electron per 1 chlorine atom. You get what I'm saying? Just a single electron per 1 chlorine atom. You get what I'm saying? So another way you can know that there's the number of electrons you can add here. Another way you can know that the number of electrons you can add here. Just look at this. Chlorine at its ground state. Remember, a ground state of every element is always what? 0. So chlorine is moving from 0 to what? Minus 1 here. Abi? So as chlorine is moving from 0 to minus 1 here, it is undergoing what? Reduction, because the oxidation number is what? Reducing. From 0 to minus 1, is it not reducing? It's reducing. And for sodium, from 0 to plus 1, is it not increasing? That is why it's what? Oxidation. Are you getting what I'm saying now? So that is for the oxidation and reduction. So don't forget, oxidation is loss of electron, reduction is gain of electron. And when you want to lose electron, it will be written on this side, the right hand side of the equation. And when it is undergoing reduction, that's gain of electron, you are going to write the electron gained on the left hand side. So that is that for that.